Sometimes we might see something like this, where an endpoint is open, it could be closed, but then it's also saying that everything to the right forever is included as part of our solution set. So how would we signify this? Well, it's saying that we're starting at 1, and then all of the values that are to the right of 1 or are greater than 1 are part of our solution set. So it would look like the set of all x such that x is greater than, oh whoops, not equal to, just greater than, because it's open, greater than 1. So this is our set notation for this one. So for the interval notation, we would have parentheses here because it's not included, and then it's going all the way off to the right. Now, as it goes off to the right, the numbers are getting larger and larger and larger, and we're approaching infinity. We're going all the way off to infinity. So this is going to be the last value of our interval. Now, we can't actually reach infinity, but we're heading toward infinity. So in interval notation, we start at 1 and we go off to infinity, And so we would use a parentheses at infinity. Anytime you have an infinity or a negative infinity, it's always going to be using parentheses because that value is never going to be reached, right? We can't actually get to infinity, so we use parentheses because it can't be included. This one's kind of crazy. So we have 1 going left and we have 1 going right. So on the one that goes left, we start here at -2 and we go all the way in this direction that way, right? And then since this is closed, we use a bracket. And then here at 1, we have a parenthesis because it's open. And then we're getting all of these values off to the right. Now, when you're writing this, so we can say in set notation, it's the set of all x such that this inequality would just be x is less than or equal to -2. And then this inequality would be, so it's this, or x is greater than 1. So this is our our set notation for this. So the interval would look like what? Well, we have a bracket here and we have parentheses here. And it's going off to negative infinity. So it's going to negative infinity. This is going to positive infinity. Now, when you're writing this out, and same within the set notation, you always write the smallest value to the left and you work your way to the right. You read just like you would read something in a book. You read from left to right. So we're in interval notation. It's going to be from negative infinity. Remember, we use parentheses with infinity. So from negative infinity all the way up to -2. Now we're going to use a bracket here because it's a closed circle, so a bracket. And then we also have this interval here, so from 1 to infinity. But we're not allowed to include 1, so it's from 1 to infinity. Now we have to show that it could be in this or this. And in set notation, we just can say or we can just list them all. But in interval notation, we use this u. And this u is actually the union of two sets. It represents the union of two sets. So it's saying it could be in this set or it could be in this set. Our solution could be in either of these. All right. And then this last one. So it's saying that our solution could be any number on this number line. Every single number is possible on this number line except for -3. Well, that's actually pretty easy to write in set notation. It's the set of all x such that, well, x cannot equal -3. And that's it. It's everything except for -3. And that's our set notation. Now for interval notation, we have to talk about how far left and how far right we can go. So again, we're going all the way off to negative infinity here. And we're getting up to -3, but not quite reaching -3. So we're going to have a parentheses here. And that's going to be the left part of our interval. But then we also have this right part of our interval. And again, it starts at -3 but doesn't equal it. So we're going to have parentheses here again and goes all the way off to positive infinity. So the way that this would look in interval notation is negative infinity up to -3. Can't include negative infinity. And we're not going to equal 3 because it's not included. Union, again, we're going from -3. Now, this time we're going all the way to the right off to positive infinity. So this is our interval notation. Now, set notation in this case looks really nice, easy compared to this. But as you move forward in math and you move forward to calculus, interval notation becomes a lot more prominent. So it's important to know how to write both of these. And we will experience this a lot in our book as well. So good luck.